Hello, welcome back to my bench. Today is just going to be a talk and tip day. I'll make some of these off and on, I guess, that don't really fix anything. We just talk about what's going on at the bench and what's new and what I've been doing. These things will be for stuff that I didn't really feel was good enough to make a video out of, or the video would have been absolutely boring or 72 hours long. But this is just to talk through what I've been doing and maybe some of the new stuff I've got. So anyway, for the first thing we're going to do is, do you guys remember that? This is a PA board out of a severely burnt up Icom IC718. And I cut out a chunk of it, and unfortunately it's burnt up inside of here, and it's conductive along parts of the board, and it's just not in good shape at all. I was hoping maybe I could resurrect this thing, but I can't. At least, not to my knowledge, I can't. So, here's what I did instead. I went out and got one of these. This is a little HF 1 megahertz to 30 megahertz amplifier. Takes 100 millivolts in, and or 100 milliwatts in, and it gives 3 watts out. When I got it, it did not work, and I played with it and couldn't figure out how to get it to work. And finally, after about 6 months, I said, you know what, David, you fix stuff. Why don't you go through this thing and find out what's wrong with it? So I did. I started on with it, and lo and behold, I come to find out that that little IC right there, which is an RF amplifier, it was shorted. Output to ground. That's why it wouldn't put anything out. So I took it off, cleaned it off, put it back on. Now it works good. 12 volts in, 100 milliwatts in, 3 watts out. That was the first step. And I said, you know what, that'll be good, because the radio itself, the Icom IC718, which is right here, it all works, except for the transmit, of course. It's even got the little filter in it. And coming out of this little plug right here, this cord, which used to have that thing on the end of it, comes 100 milliwatts of your desired frequency. So I plug that, hook that up to there, I get 3 watts out of there. Cool. Well, I said, that's fine. So then I went out and I bought that as a kit. This is not an easy kit. Not because there's a lot of stuff on the board and it's hard to build, but because it is not documented worth a hoot. The documentation not only wrong in many spots, but it's also in some form of English I don't understand. Especially the winding of these coils. It makes, not only does it not make sense, it's not the same every time you read it. Anyhow, thank you for Dad's store. I inadvertently sent him an email saying I bought this from you, which I did not, and I don't understand the instructions, because this version of it is not the version of the instructions I got. So, thank you, Dad's store. He sent me the overall of all versions of this, and I was able to finally get it put together. I've got a little SMA connector over here, which connects from there to there. 3 watts in, 12 volts over here through a little choke coil, and the output is one of those things that's inside of the radio that I stole off of another board, Yaesu board someplace, and that goes out to the filter and switching. Well, this is an RFPA 250 3HV. HV stands for high voltage. There's one on a 24 or 12, depending on what you do. You put in a little Zener diode and a dropping resistor where this jumper is. And all that does is run the 6-volt regulator back here that provides the bias for the transistors, which are big old FETs down here. Well, this does work now. Unfortunately, with 3 watts in, it puts out about 12 watts. It requires about 10 watts to drive it. I looked everywhere to find a 10 watt that'll fit. And I'll show you my problem here. These are all the pieces that came off the old board that burned up. Alright, so here's my board. I can put it right here like that and screw these down to that heat sink. Mount the board up a little bit with some standoffs. We're good to go. And I can put this guy, squeeze him right in there, wedges everybody in, and as they say, way down south, Bob's your uncle. So there, like that. This, well, that's backwards. It would go like this. And plug into there. And I have this little guy here, which would go from here to there. And then the output right here plugs into there. Unfortunately, and it works. It works fine. It's great. I have no control over power output, but I figured I'd look into that later because this isn't connected. Problem is, it only puts out 12 watts. So, I sort of put that idea away for a little while and went a whole nother direction. I took this board and where is it? Looked it up in the manual, the Icom manual for the 718, and I found this. Right there. That is the bottom of the board. Right there. It's mirrored, sort of. This picture's mirrored because you'll find out why in a minute. And you can see it's got all the traces around it. Everything I needed to look at the board. And then I did this. I went out and bought a program. This is a program called Sprint Layout. This thing is phenomenal. What a great program. This thing is like $49 49 euros, 43 euros, 49.50 bucks American. And it works fantastic once you get to understand it. the learning curve is a little bit high, but what it'll do is just phenomenal. If we look here, right now we're looking at C1, which is the copper 1 and copper 2. If I turn off viewing of copper 2, now all we got is copper 1. And if I turn on or go to copper 2 and turn off copper 1, there's the bottom of the board. Just as you're seeing it, if you were to take this board and hold it this way and see down through it. This thing is just amazing. It's just amazing. I spent 3 solid days working on this, and it was not easy. I mean, not easy at all. All of these little bitty teeny tiny holes that you see, like right here, all those guys, those are all vias that go from the top ground plane to the bottom ground plane and connect it. That took me 2 hours to figure out on its own. And it's so stupidly simple that I should have guessed. I mean, all you do is you take one of these vias here, and if you look right down here, it says how far away from the ground plane do you want this via to be as far as surround, so that it doesn't touch, and you take that down to 0 and now it touches. And it was in the manual. I'll admit I read the manual late. Anyway, so I got this thing all drawn up. I still have several hours to go through it to figure it out. I mean, make sure that I did everything else here. But when I get this done, considering the fact that I called and talked to Icom, and they told me that these boards were not available, even as a blank board. They got none, don't have any, won't have any, won't sell you one. Thank you very much, buy a new radio for $2,000. And I said, I'm not in that kind of position, so this is what I've been going through to try to get this thing going. So my goal is to take this thing, send it off to JLC PCB when I make sure that I've got everything, because right now I'm still kind of worrying about whether I got everything or not. But all the traces and everything. What's really cool, when you do this, you can set this thing for test, and you go say, well, I want to make sure that my works, and look at that, it flashes, it goes to where it's going. In this case, it's going right over here to this plug. You hit another one here, and it goes up to there. And if I hit one of these little vias here, if I can get to it, it thinks about it for a second, and then everything flashes that's ground plane. Is that like cool or what? I mean, these are connected. The ground plane would be flashing too, but it's it's just a ground plane setup. You get there by turning this on over here, and then you can also make. Let's get out of that. You can also make cutouts. Like these are cutouts right here. This one. This here is cut out, that's cut out, that's cut out. These are all holes in the board for your transistor or your transistors and stuff. Cutouts for like the big guys, and these over here, and this one up here, and this square cut out of the bottom. I don't know what that's for, but just a resistor goes there. But so I'm going to take this thing, send it off, and see if JLC PCB will print it. I already looked it up. They said a quote for this size of board is 180 by 115. They said about $12 to make it plus shipping. And if I can do that, then I will have, that's for 5 of them, I will have boards in case anybody else needs one. And if Icom wants to get back to me and yell at me, that's fine. But I asked, I worked, I tried, I went everywhere, I tried and tried and tried, and I could not find this board anywhere. It's not for sale on the internet. It's not for sale from Icom. They refuse to even mention it. I mean, you call them up and talk to them. So, anyway, that's what I'm going to be doing. If that works, that'll be really cool. So, there is one of the projects and what I've been doing. That was a lot of work. Alright, so what else is going on? Close that. Let's see. Oh, yeah, got a new toy. I got this. This is a capacitor tester, a blue capacitor tester in circuit for ESR. It came as a kit, was about an hour and a half's build, not hard at all. 9 volts, battery runs it. You can hook this up AC or DC. It comes with instructions and turn off the go to sleep light here. But I'm just going to use it like this with batteries. 9 volts are, well, they're expensive, but they're okay. Anyway, so I got this thing a few days ago, well, like last week, and put it together, and I love it. But we're going to go through and show you how it works and if it works. I also got, pardon me, this. Some of you know me and what I do. I fix a lot of things like Symmetrix 528Es and other stuff with service mount caps and resistors and stuff like that, like the one I did for the radio station where the little resistors and caps and stuff were off burnt up on the board. And I decided, you know what? The way I've been doing this before, 2 soldering irons, press down on the little bitty pieces parts and wait till it gets hot and pull them off. And unfortunately, that has a tendency to kind of rip the boards up. So I bought one of these. This is cool. And not very expensive. I think this was $60, somewhere around there. The tips leave a lot to be desired, but we can work on that, I suppose, somewhere along the line. But it's still better than screwing up the board. If you squeeze them, they come together on either side. And we're going to show you how this works and if it works. I will say, from experience with this now, though, that it's for desoldering. Soldering is not good with it. We'll put this back over here. It comes with this little remote here. It's made specifically, I think, for moving around. I don't know why, but the ones you buy that aren't are like $300. It's ridiculous. This is CSD safe. It means it's grounded to the ground lug, and it is pretty quick and coming up to temperature. If we can see this, I got it set for 380 something for our little demonstration here. Yeah, 385. That's a little high. It's got a little blinky light that tells you that it's up there. And then this, you just gets out of your way. Now it will shut off after 10 minutes. So, all by itself. So let's tell you what, let's get a board, get something here that we can play with here. This is an old 528E parts board. This has got some components on it. Specifically these little service mount capacitors a couple of other capacitors, some bipolars over here, you know, and basically resistors and stuff. And this is what this is a pieces parts board of those that I fix. This is just for, hey, this D53 is bad, go get another one. Anyhow, so here's how this works and what I go through when I do this. What I used to do, take the cap off, test it. Well, in the case of these things, just replace them, you know. And for these, I just replace all of them. It's a flat rate. They just all get replaced along with the switches. So this poor thing has just been beat to death sitting over here. But the tools that I use to do this, if it's something that I don't have and I can put it back in, I've got one of these little guys. These are okay. The reason I use them is because they're quick. So what we're going to do is we're going to take this to measure it, the capacitor, which it seems to do a fairly good job of in-circuit measurement. We'll put it on capacitor. This has an identify, forget it. Just don't even bother. All right, so we're going to take it and we're going to look at this little cap right here. Let us get you down here so you can see what I'm doing. We're going to take a look at, quit waving about, thank you. This little cap right here and see what it says it is. Well, it says 1.15 nanofarads. And this is actually a 4.7 35 volts. So we know that we're pretty much guessing. I mean, let's try another one here. Let's try this one. This says 12 picofarads. Or wait a minute, it came up for a minute there. 13. In-circuit testing of the value of capacitors is iffy at best. 1.03 microfarads, it says. All right, so we're going to take it. Remember, we'll check this one because that's one we just did, and we'll check it on here. You turn it on, short the leads together. I got a couple of little pieces here. Hit the button again, zeroes it out, and then you test your capacitor. All right. I am on that capacitor, and that capacitor is saying nothing. It's just flashing. All right. This thing goes to 99 ohms of ESR. Let's see if we can find one that isn't bad. This one, see, says 30 ohms. What's this one over here? Too high, too high. How about you guys in the power supply? There, that one's 1.9 ohms, which I can live with, a 4.7. That's good. And this one over here is 2.1, which is okay. I can live with that too. But if we go and look at these, what do we got here for let's see, for capacitance, if I can get on it, it came up, said 51 there for a minute. Very hard to get on these. Wish I could get it to stay. You got to kind of catch it. See where it said 55 there for a second? Anyway, and then we go over to this one. That says 670 nanofarads. Alright, so basically it's measuring them as bad. But you can't trust this. You can't trust any circuit capacitor tester for value. Anyway, so we're going to look at this, and we're going to do it by taking it out because we've sort of decided that it isn't any good just by looking at it. You have to put a little bit of solder on these guys. So we're going to take this one right here, heat them up. I can see it starting to melt. Whoops, slid off of it. That's not good. Whoa, see what I did there? That's what you stand a chance of doing no matter what you do. Let's try another one here. These boards, I'm telling you, these boards are just as crappy as can be. That one back there wouldn't be terrible because I would have to, we'll set this aside and we'll come back and check it. Let's do another one. Actually, that's the first time I've done that since I got this. Come on, heat them up. It takes a little while, but if you do it with 2 soldering irons, it's quick. But you do tend to have it, you will rip the pads right off the board. There we go. That's it. Took it off. And I don't have to repair the pad. So, anyway, there's our capacitor. Now, let's take our capacitor, our little capacitor meter here. May as well get this other one while we're at it. And we'll check one of these guys. See what it says about that. No. That's one thing I don't like about this is sometimes it thinks you touched it. I'd rather have a switch than a touch. That says 37 microfarads, which is about right. It's well, actually it's 47, so it's not even close, but it's in circuit, so you don't know. I don't care about 0.9 on this. And we'll measure it here. And it says 14 ohms. So, we'll pull this out too. Now these guys I don't use the tweezers for. The way you actually do this, at least in my opinion, the best way to do this is to heat them up like that. I'm sure this is bad, and I'm going to call it bad. Snip it off down to the board without taking out the traces or the pads. Heat it up a little bit. And that's a tight one. You kind of wiggle it back and forth until you can feel it fall out. Why do I always have to get the hard ones when I'm doing it on camera? There we go. Got it. And I did not rip anything off the board. So let's put that aside. Alright. Remember this thing said 14 ohms? Well, let's measure it and find out. Here's my meter. This is non-polarized. Of course, this meter doesn't care if it's polarized or not. It doesn't care. So we're going to measure it. And it is 5. I found that in circuit, usually it's about twice as bad. It shows twice as bad as it really is. This is a 47 at 25 volts. So if we look at our little legend here, we're going 10 to 100. So I think 10, 20, 30, 40, 50, 60, 70, 80. I think this is how this works. At 25 volts should be 2. And it's getting worse. You see that? It's getting worse. That's a bad cap. And it said it was a bad cap. Now, just for fun, let's see what this says. $32 micro, 31, 30, 26, somewhere around there. That's not a good cap. All right, here's our little one. Now remember, this guy was, it didn't show anything. It just was blank in circuit. And capacitance, it didn't show a capacitance. So let's try and see if we can get this on here. $100 nanofarads. Yeah, we know that ain't right. But let's see what the ESR on this one is. Bring it over here so you can see it. It won't even read it. Why won't it read it? Well, I'll show you. We'll pull our little leads up a little bit, just so we can get to it. We'll get our little magic box here, and we'll hook it down to there. Well, maybe. If I can get my fumbly fingers to work. These are non-polarized too, also, and there we go. And turn it on. It's a capacitor, 4.070, so it's correct. It's 4 microfarads at 0.14K, 140 ohms. That's why this won't read it. It only goes to 99. Anything over 99 is just junk. So, you know, anyway, that's it. As it turns out, with all these guys here, it is virtually always just replace it. I mean, don't even try. Just replace the caps. These guys over here, these over here. Now you got to be stupidly super careful if you work on these, because these guys, I don't know if you can see how big these traces are. Like over here, they are teensy, and they will come off the board if you sneeze at them wrong. Here's, well, just to show you, where'd I take off that? Here it is. Not that. We'll do this. Okay. Here, somewhere is where I took that capacitor off. Right there. Didn't actually rip the pad off the away completely, but it took it off the pad, off the board. I mean, I think they glue these down with Elmer's. It's just awful, awful. Anyway, so these guys just basically get all the switches replaced, because what happens is these things go in and they stay in service inside of a box, and the reason all the caps go bad is because they're inside of a box with absolutely no ventilation, and they just dry the caps out, and they never get touched. And the switches, the copper flows across each other, or the silver flows, whatever, is in the switch that they have, and it won't work anymore. If it doesn't get used, if it never gets used, they won't switch anymore. So you replace the switches. And the way I've found to do those too, and I found this out just kind of recently. So let's take a switch here. What I'm going to do, watch this. This had me going for quite a while. Basically, it's like capacitors. You cut the right off to there, flat down, just like that. So it is flat as you can get it to the board. See? Nothing sticking up. Yeah, hit it with solder. I found that solder wick doesn't work very well, mostly because these things are through holes, and the other side of several or most of these is ground, or the bottom is ground or something. It just sucks up the heat. Anyway, so we got that thing sounding like that. Grab a hold of the switch. It's going to get hot. Turn your soldering iron sideways. Heat up all of them at the same time. Whoops. Heat them all up at the same time and give it a little wiggle. Heat up the other side at the same time. Give it a little wiggle. And out it comes. There it is. And I didn't rip anything off the board. Didn't rip anything off the board. Now you can take your power solder sucker and suck out the holes just as easy as can be. Trust me, I've tried hot air guns, I've tried solder suckers, I've tried solder pullets, you know, the little snap things that go solder wick. I've tried everything known to man. That's the easiest way to do it. Right there. Now the switch isn't of any use anymore because the leads are too short to go into most boards, but it was dead anyway. Alright, so that's that. What else we got? Did I do anything else that was kind of interesting? Oh, yeah, I built a new little box. This is simple. Thank you, TRX Lab. I built your little box. Just an RF sample. You can go look up RF sample from TRX Lab. It went in this little box. It has a goes in and goes out of. There's a toroid coil inside of there on around just a bare piece of metal. Comes up to a 22 ohm wire wound resistor with a 22 across it, and it comes to a sample out. So I can get between, it's about a max of 40 dB down to about 8, somewhere 6 or 8, somewhere around there. So that I don't blow up my spectrum analyzer that I've spent years trying to find. Anything else that's new? Oh, yeah, I got this. It's just a little pulse generator, Pwm and pulse generator. Puts out pulses. Plus it also will put out PWM, and it'll do pulses by width and time. Pretty cool. Little PC printed box, or 3D printed box. But it works, and it gives me, if I want to put something in circuit, test in circuit, and I want to see if it's working, I can put this thing on like, give me a pulse every 5 seconds, and we'll see if it's going through the logic gates. Perfect for that. I think at $12. It wasn't very much. It was pretty cheap. I think the switches and it cost more than it did. I guess that's about it. That's all the new stuff I've got. But it's fun stuff. I really like it. It's I'm printing a box for this because I want it to stand up like this so I can see it all the time. But it's, hey, my new toys and plays and a little bit of tech tips, and hope you enjoyed it. Don't forget to subscribe and ring that bell so that you can see when I'm doing stuff. Give me a thumbs up on these things because I really appreciate that and it helps. And talk. I mean, let's have some conversation on this. And if you like this kind of a video, let me know, because they're fun, they're easy to make, and you know, this isn't a video. You've seen people build stuff. I can't do the video on the Icom yet because I still got so many pieces to go. I will do a video on that when I get it done. If that board comes back, I'll do a video on that. I've got a bunch of pieces of stuff to fix. People have sent me in, and oh my, whoever knew that a little YouTube channel would turn my hobby into a full-time job. Anyway, thanks guys. Till next time, don't forget to subscribe.